What's going on, everybody? Welcome back to my YouTube channel, Richard on Data. And if this is your first time here, my name is Richard, and this is the channel where we talk about all things data, data science, statistics, and programming. So subscribe for all kinds of content just like this if you haven't already, and hit the notification bell so YouTube notifies you whenever I upload a video. So we're going to do another R tutorial today, and it's going to be on base R. So functions and characteristics of R that don't require you to dabble into packages at all. So once you got R installed, and hopefully you're using RStudio as your GUI for R, all these functionalities are right there, and a lot of these are things that you probably should get acquainted with sooner rather than later, because a lot of the things we're going to walk through here, they're either essential or really helpful things that if you don't know that they exist, you could be just taking a lot longer to do things than you should be. Now in this tutorial, I'm going to be going back and forth a little bit between this cheat sheet and an R markdown document that I've drawn up for this tutorial, and that's just because there's a few functions here that I think it's really helpful for you to see exactly what's going on there. But for the most part, I'm going to be walking through this cheat sheet. Now, this cheat sheet, I'm going to have a link in the description of this video. Similarly, this R Markdown document is going to be available on my GitHub, also in the description. So, as usual, before we get into this, number one, please take 1 second of time to smash the like button to this video, because that really does help my content reach a larger audience. Also, in the description, I will have a link to my Patreon account, so if you guys would be willing to support me that way, it would be massively appreciated. Alright, so there are 2 pages to this cheat sheet, and for the most part, I'm going to go from one page to the next, and I'm going to go down each of these columns. There's a couple points in which I'm going to have to jump around because I think a couple of the functions are somewhat related to each other, but for the most part, that's what we're going to do here. So the very first function on this whole cheat sheet is arguably the most important function in the entire R ecosystem, and that's the question mark function, also known as the help function. So when you run this for a particular function, it's going to pull up the help documentation for it. So let's see an example of that. If we go into R here, and I'm going to run a couple chunks of code here, but if I go ahead and do question mark for the mutate function, which I've been using here, I just run the question mark function like that. Bam! It's going to pull up that help documentation on the right side here. So I do this all the time. It's going to take a long time before you memorize all the syntax for every function that you could possibly use. Most people are never going to get there at all. So get very comfy with doing that. Similarly, if you want to pull up the help documentation, let's say for an entire package, you could do that by calling this help function directly. So say help package equals dplyr in parentheses. That will pull up all the functionality on CRAN for the dplyr package. So that's awesome. So this str function is another one of the absolute most important functions in all of R. So let's see an example of that. Now, I'm using the iris dataset just because that's an absolute classic. Comes built into R. You can pull it into your environment by using the data function and then iris inside of it. But if we just look at the str function, let's take a look at it. Let's use str of iris, and then bam, look at that. We see the structure of this data set, or this object iris. We see that it's a data frame with 150 observations of 5 variables, and it lists all these variables with their names, as well as what types of variables these things are, and some examples of them. So 5.1, 4.9, 4.7, all realizations of the variable sepal.length, as well as the species variable. That's a factor with 3 levels. Super helpful stuff. Now, very closely related to the str function is the summary function. This is going to give you a little bit more information. Specifically, it's going to give you things like the 5-number summary in the case of these continuous variables. Now, species is a factor variable, so it's going to break down for each of the different levels of that factor, what are the counts for each of them. So very helpful. And if you want to do only one variable at a time, you can do that, but iris has only 5 variables to it, so running the summary for the entire data frame I think makes a lot of sense here. Now, one other function which you should be aware of is the names. function. Now, this is really nice if you just want a quick and dirty overview of what the names of the data frame are. Like, here we go. We've got a character vector of the names of Iris. And if we want to do something, like we want to modify the names or we want to, pass it inside of another function, using the names function makes that super easy to do. So we go back over here. By now, if you've seen my previous tutorials, which I recommend doing so before this video, obviously you'd be familiar then with install.packages and library. Your first go around with things, you have to run install.packages so that you have an installation of the package available for R to find. Then once that's done, you use the library function. You'll load all the functions in that package into your session, and then you're good to go. Data, that function you've already seen. I did that to bring the Iris data set into my environment. Now, if you've seen my first R tutorial, you saw where I did this dplyr : select thing. And the reason you may need to do that is because taking this function select, for instance, the select function exists inside the dplyr package, but it's also inside a package called mass. So when that happens and you have multiple of these packages and there are conflicts like that, R can get confused, like, okay, which package do you want to use the select function from? So if you put this dplyr : prefix in front, that removes that confusion for R. So sometimes you'll need to do that, particularly with the dplyr package. Working directory stuff, so the getWD function, that will tell you what your working directory is. As far as setWD, you can specify a file path inside of that function and it will change your working directory. Now, you can specify that a big long file path. Let's say you're doing something like reading a data set in, or you want to write a data set and have it show up in your machine somewhere that you can access. You could write that entire long file path, but if you're just working inside of one folder, just write that file path to that folder inside of setWD, and then it's going to make your life a lot easier, because you could just write, jumping ahead a little bit here, file.text, let's say you're doing a write.table, file.text, that would output right to that folder that you've specified inside of your working directory. So just a couple more things which highly recommend getting acquainted with here. Now, the second column is all about things pertaining to vectors, and most of this is very straightforward. So you've seen this C function if you saw our tutorial 4 that I did, but let's say you have these elements 2, 4, and 6. Put them in this C function. C stands for concatenate. That basically bundles these things into one vector. Then you can work with the vector in and of itself. This 2:6 thing is an integer sequence, so that'll return 2, 3, 4, 5, and 6. This seq function is a nice one. The seq stands for sequence, so the arguments to it are the minimum, the maximum, and by. So you could do minimum equals 2, maximum equals 3, and the increments are 0.5. So you would return 2, 2.5, and 3. Similarly, you've got the rep function. Now, it's got these arguments times and each, and the difference is, let's say you've got rep 1:2 times equal 3 would return 1, 2, 1, 2, 1, 2. Then rep 1:2 each equals 3 will return 1, 1, 1, 2, 2, 2. So very helpful function for spinning some data together. That's I use these quite frequently. Now, for some of your core vector functions, you can do sort. That will just sort your vector. The default is alphabetically, but you can do things like reverse alphabetically. For instance, the rev function will help you do that. Table will return your count. And then unique, that's a super helpful one because that will show you just your unique values. Analogous to something like a distinct in SQL, if you're familiar with that. Now, when you start subsetting and selecting elements of your vector, as a general rule, whenever you see these brackets, that's going to involve some form of subsetting. So x bracket 4, that's going to return the fourth element. You can do this in a inverse fashion. So x negative 4 will return all but the fourth element. We can do a sequence here. So x brackets 2 to 4 is going to return the second through fourth elements. Similarly, we can make that negative. Or we can just do the first and the fifth element by just putting those inside of a vector. This concatenate 1 and 5 will return the first and fifth element of vector x. Then, just one thing to keep in mind here, we've got the equals equals. Now, equals in R, just a single equals is typically an assign operator, but equals equals is a logical check. So when we put x and then in brackets x equals 10, that's going to subset to the cases where x equals 10 is a true statement. So subset to elements that are equal to 10. Similarly, we could do that with elements that are less than 0, and you've got your operators for equal to, not equal to, greater than, less than, and so on and so forth. This in operator is a super helpful thing, which I use all the time. You can subset to x being in the set 1, 2, and 5. Again, I use that all the time. And then if you have names to your vector, for instance here, you could subset to the element in x that has the name apple. Moving on to the last section of this cheat sheet, we have our for loop and our while loop. Those are the key loops inside of R, as well as the if statement is super important as well. Now, the key syntax piece here is that you do need these curly braces, so just keep that in mind. For some other things, like the spacing here and the indentation, R is typically pretty forgiving with that kind of thing, so just set this up generally with making sure you have the curly braces and that it's generally readable for an audience that's not you. Now, a couple things that I want to show here, because there's also a key function called the ifelse function, which is not on this cheat sheet. So I'm going to use the ifelse function to create a new variable inside a new data frame that I'm going to call iris2. Now, I want to create a variable called large sepal, and I'm going to use the ifelse function to do that. Now, how the ifelse function works is there's going to be some statement to evaluate, is that true or false? Then if it's true, it's going to return a particular value. If it's false, it's going to return another value. Now, I want to check for is sepal length greater than 6 and sepal width also greater than 3. Now, if that's true, my variable large sepal is going to be equal true. If this is not true, it's going to be equal false. So let's just do that. And bam, I've created a new variable called large sepal, which is false 127 times and true 23 times. This is typically the kind of context in which I'll use the if-else function, but I find this super helpful, and it can be a lot just syntactically cleaner than writing a whole bunch of if-else statements. The other thing I'm going to show you is creating a function. So what I've created here is this custom function called fair to cell, and what I'm doing here is I created a vector called fair. These are just temperatures here in the Detroit area where I live that are in Fahrenheit, and I created a function which is going to convert a vector of values into Celsius. So it's just going to perform the conversion formula that you use to go from Fahrenheit to Celsius. So just create that function x, and it's going to return, I'm going to round this new variable y that's created in the middle of this, and I'm going to store that inside a new variable cell, and then I return cell here, and bam, it worked to convert my Fahrenheit vector into Celsius. So it's generally a really good practice to get into to write functions for things that you're going to repeat more than once. And it's also good practice because over time you're going to end up doing a lot of the same kind of functionality over and over again. So if you've written functions for things that you do a lot, you can end up saving yourself a ton of time. So that just about covers this section of the cheat sheet. Again, if statements and functions as we go down, things like reading tables and reading CSVs, writing tables and writing CSVs are things that you want to be familiar with, loading and saving our data files, and then the conditions. Moving on to the second page of this cheat sheet, we have our variable types to start this off. Now, if you've seen my R tutorial 4, you should be familiar with these already, but you've got as.logical, as.numeric, etc., etc. That will help you convert a variable from one data type to another. So, clean and easy to work with. The next thing are your math functions, And now, it shouldn't surprise you that R was built by statisticians for other statisticians, so there's a lot of math options that are available to you. So you've got a natural log function, exponential, max and min, round to so-and-so decimal places, round to so-and-so significant figures. There's a correlation function. You've got sum, mean, median, a quantile function for, let's say you want the 25th quantile of a vector. You can return that. There's a rank function. There's variance and standard deviation. And then most of you should be familiar with this one already, but obviously you've got variable assignment, and the assign operator is this arrow thing. So let's say we want this scalar element of A, it's going to be one-dimensional, and we want it to be equal to apple. We can just assign apple to A, and then when we call A, bam, it's going to output apple. So lastly, for this section here, then we've got the environment. And no, I'm not talking about the thing that's all around us that has the air that we breathe and the water that we drink and all that stuff. This is easier to illustrate inside of R, because for newcomers to programming, a lot of you may be unfamiliar with the concept of an environment. But if you think through what I've done so far in this script, I created this thing called dataset, as well as iris and iris2. Now I can access those whenever I want and do whatever I want with them. I've got these vectors, sal and fair, as well as this function that I've created. All of this is inside of my environment. Now, if we want to return a list of the objects that are already loaded in the environment, we've got this ls function, and bam, that's going to output for us these objects that we can work with, as well as the fair to sell function here. Now, if I wanted to, and I just wanted to remove everything inside of my environment, you can do this rm list equals ls functionality. Now, watch what happens to my to everything that's listed in my environment on the upper right side here when I run this. I'm going to run it, and bam, my environment is empty. So that's a clean thing that you can do sometimes just to free up some space for yourself. And this is something that, if you read a lot of people's code, you're going to see this right up front. Second column of this page of the cheat sheet is all about matrices, lists, and data frames. So if we step through this, starting up the top, we have matrices. Again, you've seen this if you've seen our tutorial number 4, but just to go over this again. If you have a matrix, let's call it M, then you do M2, comma, that's going to access your second row. Similarly, if you do M, comma, 1 in brackets, that's going to return your first column of M. And then, let's say you do both of them. So you do M2, comma, 3. That's going to go to the second row and then the third column and access the element in that location. So rows followed by columns is how that works. Then you got some other matrix operators like your transpose and your matrix multiplication and your solve function. Now I'm actually going to move on to data frames next, because I think for most people these are a little simpler to understand. And you can put a data frame together in this fashion right here using the data.frame function. So in this example here, I would create a data frame with 2 variables. One of them would be x, it would be just 1, 2, 3 here. And then my second variable would be y, and it would have values a, b, and c. Now, as far as how you subset this, R is amazingly flexible with this. Now, I went back through this script and I brought everything back into my environment, so don't freak out too much here. But I have got my iris data frame back in my environment here. Now, if I want to do iris $sepal.length, that's going to access the variable sepal.length from iris. And this is by far the most common way that you're going to see people accessing columns of data frames. But if I just use the matrix notation, I could do iris, then in brackets, comma 1, and that's going to return the first column of the iris data frame. Or I can just use my list notation. So iris, and then in double brackets, 1. Now, if you've seen my R tutorial 4, I went over the fact that a data frame is a special instance of a list where you have vectors that are of the same length. All a data frame is a list. So the first element of it is the first column of it. So the long and the short of it is all of these 3 approaches for getting my first column return the exact same result. Now, similarly, I've got to go over accessing items in lists. Now, this is the code that I created from our tutorial number 4. Now, you should get acquainted with just looking at the structure of a list. Now, this list 3 that I created, it's a list that has 2 numerical items here, the number 1 and the number 4, but also a data frame, or actually it's a tibble here, but it's a tibble with so-and-so variables all in it. Now, when I run the str function for that list, it's going to output all of that. So I see every component that's going into, well, really I see the components of the components of my list. Now, there's a number of different ways to access the elements of a list. Now, if I do a single bracket here, that's going to default to returning a list. So when I did list 1 and then a single brackets 1, that returned a list that has just one item in it. It's just the number 3, but this thing that got returned is a list. However, if I do the double brackets, that's going to return the first element of that list without taking that extra step of converting that into a list. You see the difference here. The single brackets returned a list, and the double brackets returned just a one-dimensional numerical item 3. Similarly, if I have names here, I can use the names in the double brackets to access the element of list 4 that's called scalars. And then similarly, if I have double brackets followed by a single bracket, I'm accessing the first element of the first element of list 4. If we look at list 4 back up here, we had list 1, list 2, list 3. First element of list 4 is list 1, and then the first element of list 1 is 3. And would you look at that? I returned 3 here, or actually inside of a list, because once again I'm using the single brackets. Now, to wrap up this discussion on data frames, a couple more functions that you absolutely need to be familiar with are cbind and rbind. And these stand for column bind and row bind, respectively. So I'm going to show you an example for each of these. Now, for cbind, I'm going to demo the rnorm function for you at the end of this tutorial. But for now, all I'm doing is I want to create a vector of length 150. There are 150 rows to iris, and the most important thing here is I want these things to be of the same size. So then I want to create a new data frame called cbind example, and I'm cbinding the iris data frame with this new noise vector that I created. Once again, they're both of size 150, and then when I look at the cbind example, bam, I've done that with no problem. I've added this noise variable to the end of the iris data frame to create a new data frame here called cbind example. So cbind is probably the one that I use the more of the two, and it's pretty flexible. So if you wanted to cbind a data frame and another data frame, you could do that. I did obviously a data frame and a vector here, and as you see, it works awesome. Now similarly, you've got rbind. Now, what I'm going to do here is I'm going to create a new data frame called extra rows here, and it's going to be the same number of columns as iris, but it's going to be 50 rows. So I'm going to do that, and just take a look at what I create here. I create an rbind example, which is going to be the row bind of iris and extra rows. Now, just looking at the structure for each of these things, iris was 150 rows with 5 variables. This extra rows thing I created was 50 rows, 5 columns, and then bam, this rbind example that I created has 200 rows and 5 variables again. So cbind and rbind are going to make it super easy for you to work with data frames. We're going to go back to our cheat sheet here, and we're going to go to the third column of the last page here. Now, it has some stuff for dealing with strings, and this is all very important, but I'm going to cover this stuff inside of a separate tutorial. I'd say the most important thing here is the paste function, because that's going to join multiple text vectors together. And also you have the string-r package in the tidyverse, which makes it a lot easier for dealing with your character data. Now, the next thing that I really want to show you is the cut function, and what this is going to do is it's going to take a numeric vector and it's going to cut it by sections into a factor. So let's show you how this works. if we go down here, I'm going to use this two different ways. So I'm going to create two new variables. They're going to be called sepal group 1 and sepal group 2. Now there's a couple different ways that we can use the cut function. One of them is to manually specify how we want to cut this variable up. And the other way is you just specify the number of cuts, or the number of breaks rather. So you're going to break it into the bottom 50% here and the top 50% because I've specified only 2 breaks. So if we do that here, I'm going to look at the data frame first. For that first sepal group that I created, notice that I specified cut points 5 and 5.5, as well as, well, the minimum of the variable sepal length was the first thing I specified. So we've got one group 4.3 to 5, another group 5 to 5.5, and then similarly, it automatically figured out that 6.1 was the median, so we've got this new variable sepal group 2, which goes 4.3 to 6.1, and there'd be naturally another value for the value that's the median to the maximum. So cut will save you a ton of time. Don't be like me and ignorant of this function when you first get to learning R and create these by hand, because cut makes your life a lot easier. Now, basically, the rest of the stuff on this cheat sheet is all statistics and distributions related, and I'm going to show you all this again inside of this R document here. So, moving on to some really, really fun stuff and critical for any person who's even, got their feet wet in the statistics world is the LM function. And so, how this works is you're going to specify a formula, then the data where this formula comes from, so the data where all the variables are coming from, basically. And then the easiest way to access all the information from the model that you create is to use the summary function. So let's just look at a sample linear regression model here. We've got the formula for that regression at the top. We have a 5-number summary of the residuals. Then we've got the intercept as well as all the slope estimates, the standard error for all those slope estimates, the t-statistic for them, as well as a p-value for them. And then to make your life easier, it's got these significance codes side by side these, so you don't have to spend too much time looking at a big list of these and figuring out, oh, well, is that significant? You've got naturally a residual standard error here, a multiple R squared and an adjusted R squared, and then an F statistic for the broader model. You've also got the GLM function, which is for generalized linear models. Probably the most common one that everybody's going to use is logistic regression, but you've got, you could specify family equals Poisson for something like a log linear model, but apart from that, the syntax is incredibly similar here. I'm going to create a logistic regression here, and I have very, very similar output here. I have my regression equation up top. I have the deviance residuals. Very similar output here with the estimates, standard error for them, a z statistic, and a p-value associated with those. And then my null and residual deviance and AIC. Last but not least is working with distributions. Now, there are 4 key functions for working with distributions here, and I'm going to show you an example for all of them for a normal distribution. So, starting with rnorm. This helps you generate randomly from the normal distribution, and the syntax here is, I want to generate 20 observations from a normal distribution that has mean 0 and standard deviation 1. We do that, and then, bam, just from eyeballing these values here, looks like realizations of a normal random variable that has mean 0 and standard deviation 1. There's the lesser used density function, and we're going to evaluate the density at point 0 for, again, a standard normal distribution. That comes back at 0.398. We've got a probability function, so the probability of getting 1.96 or smaller from a standard normal distribution. Anybody in the statistics universe knows this right off the top of their head. That's 0.975. 0.975 is the probability that you see a value of 1.96 or smaller. And then you could do 1 minus that, obviously, if you want the complement. But then we can do this in reverse. So if you want to do the quantile function, so plug 0.975, what is the value for which point we get to the 97.5th percentile of a standard normal distribution? Bam, we have 1.96. So there you have it. This cheat sheet, I think, provides a really comprehensive rundown of some of the most important functionalities in base R. And if you're a beginner to R, I strongly recommend bookmarking this cheat sheet. Again, the link to it is going to be in the description of this video. And naturally, you do have to get used to using other packages for the functionalities they offer. But just get used to using the base R functions, and obviously getting used to calling the help documentation so you remember the syntax, so you can just look up the syntax, and this doesn't just feel like memorization to you. And at a certain point of time, it's going to just feel like second nature to you, and you're going to be able to do a lot, even without even having to dabble with packages, just using base R. So that's it for this tutorial. If you enjoyed it and you found it of value, please consider sharing it. Otherwise, again, hit the like button, and then I'll see you all in the not-so-distant future. Until then, Richard on Data.